Hi, I'm Arthur Wang. This is my buzz card. So, this is my presentation on how Taylor series and polynomials can be applied to computer science. So, Taylor series and polynomials, as we have learned, are very useful as writing mathematical functions into these forms allows us to approximate the value of a function to a predetermined error. If we want less error and consequently a better approximation, we can simply take more terms of the Taylor series, just adding on the terms of sequentially higher degree terms of the Taylor polynomial. So the graph below's actual equation is e to the power of x. So, the Taylor polynomial of order k, generated by f of x at x equals a, is given by the general form, and where each term afterwards is given by the f kth derivative at a over k factorial times x minus a to the power of k. And we can see over on this graph where it would be the green line would be the graph of e of x. It's almost hidden behind order 7, but you can see as order 2, you have it down here, order 3 is over here, order 4 is here, and then order 7 is basically on top of the actual graph because it's a very accurate approximation at that point. So as the degree increases, the approximation gets more accurate. So we have this application to computer science. So algorithms and functions used in applications such as calculators can utilize such approximations. While it may not be inherently obvious, digital calculations that involve functions employ Taylor series and polynomials to approximate values. For example, bearing in mind that a Maclaurin series is a Taylor series where x equals a, to find the value of sine 1 in radians, a calculator will use the Maclaurin series expansion for sine x that we found earlier, or it has the form and it will equal to sine x equals x minus 1/6 x cubed plus 1/120 x to 5th minus 1 over 5040 x to the 7th, and so on. So the calculator substitutes into as many terms of the polynomial that it needs to in order to get the required number of decimal places. Let's say our calculator has 6 decimal place accuracy. We simulate what the calculator will do by substituting x equals 1 into each of the terms and stopping when the accuracy is achieved. So what does this mean? Since computers cannot store literally infinite possible data and answers to calculations, they can utilize useful representations such as Taylor series or polynomials that can be used to calculate extremely precise approximations of things such as functions. Although we can also technically calculate such approximations of functions by hand, computers can leverage their computational power and calculate these approximations way faster than a human can. So these are my references and image sources. So the links that I used are right here. Thank you for watching.